Hello everyone, this is Vahe for the Experiment 9 reference video. So this introductory video hopefully should get you ready for experiment number 9. We'll be using pretty much all the parts that we have learned before, but we have some additional parts. So that's what I'm going to go over, and I'm going to suggest ways of putting those on the board properly so that you have the least amount of trouble with the layout and then the measurements. So what you'll find is that the actual layout or construction of the circuit is going to probably take a little bit of time, not too much, but the actual measurements will be very easy. So just remember that most of it is just setting up. The measurements are going to be not that difficult to do. In fact, you're going to be using multimeter again. So let's get started. So in experiment 9, you will use the LED again, the red LED, and you've already seen this in the previous experiment, so I'm not going to spend too much time on it, but you know that it has two leads on it. So it's got a long lead and a short lead, and the short lead is the what's called a cathode. So we have a positive side and a negative side. Positive side is referred to as the anode, and the negative side is referred to as the cathode. And there's usually a symbol that's shown as the ones that you're seeing on the screen right now. Typically, the longer leg is the anode, and the shorter leg is the cathode. Also, if you look from the top, you'll see that the one side is flat, where it's really should be circular. So the flat side is actually the negative side. So if you look at the lead under that side, you'll see that that's actually the cathode. So you've seen this, and I won't say much about it, except to say that when this LED conducts, the red LED that we have, you will have approximately 1.8 volts measured from the anode to the cathode if the LED conducts. Now, we have a new element, which is called just a diode. So it's called a diode or a rectifier. And, it's just pretty much the same symbol as the LED, but there's no light in here. So when it conducts, you don't see it, obviously. So there's an anode and a cathode. It looks kind of like this. It looks like a cylinder with two leads coming out of it. And the one side has this typically a silver stripe, and the silver stripe refers to the cathode side of the diode itself. So that's what we will see. The particular model that we're using is called a 1N4004, and this device will conduct 1 amp in the forward direction from the anode to the cathode, and then it will block current from flowing in the other direction from the cathode to the anode, and in blocking so it can block reverse voltage from the cathode to the anode to a level of 400 volts. So it can block 400 volts. And when a diode conducts in the forward direction, there is a small voltage drop from the anode to the cathode of about between 0.5 and 0.9 volts. We typically take that to be about 0.7 volts. So when the diode conducts and you put your red or plus multimeter terminal plus probe on the anode and the black or the minus probe on the cathode, when the diode conducts, you should see about 0.7 volts. But that could vary. That could vary from 0.5 to 0.9 depending on how much current you're passing through. So on the average, we take about 0.7 when we're doing calculations by hand. Anyway, this is the diode. You have one in your kit, and you have several LEDs in your kit. We'll just be using one of those. The two circuits that we'll be doing, and this will be in your the experimental write-up when I actually finish it later on today, or maybe tomorrow morning, Monday morning. You'll be putting together these circuits, and I mean the measurements will be fairly easy. you'll be just measuring the voltage across the LED or voltage across a diode. And on the resistive side, there may be some other resistors we may try and place on 1K and see what happens to this diode voltage. But these are very simple circuits, and the typical way we're going to set them up, I'll show you on the schematic layout here, is going to look like this. You have the positive lead over here for the 5 volts. So 5 volt supply will be on this top lead, for example. Okay, these are all examples. You can do it any way you like. These are just suggestions. Here's the negative lead, and we're going to set up the LED, anode here, right? So this is going to be the anode, and this is going to be the cathode, okay? And we'll put a 330 ohm resistor. So this resistor right here is a 330 ohm resistor, which will go from the supply down to the resistor, and then this cathode will be tied to ground or the negative side. And very similar with the diode circuit. I put both of them on the same diagram here, or the same a proto board. You can too, actually. You can do these together. So this is as I said, a 1K resistor, and here's our diode. Anode on this side, right here. That's the anode side, and on down here is actually the cathode. Here, that was the anode, and the cathode is tied down to ground, and we'll be measuring. So you'll be measuring basically this point right here, and this point right here for the two measurements. So hope that's clear. And again, on the reference diagram, I put that here. You can take a look at it, as a reference, as a suggestion. But there are different ways of doing this. I'm not saying this is the only way. As I said many, many times before, these are just suggestions. Okay, now let's move on to the next element. And the next element we'll be using, and this is the only other new element that we're using, is called the NPN Bipolar Junction transistor. This device has 3 terminals, and those terminals are called collector, base, and emitter. And here's the diagram for it. So collector is number 3 over here, base is 2, and emitter is 1. So basically what this device does, the way we're going to use it in EC115, is it acts like a switch. Okay, so if the voltage at the base, which is number 2, is high, okay, high voltage, relatively high voltage, then current can flow from 3 to 1, from the collector to the emitter. If the voltage at the base is relatively low, there is no conduction. So it acts like a switch, right? So if the voltage is high, that's like a closed switch from 3 to 1. If it's a lower voltage, open switch from 3 to 1. So you can think about this as a normally open switch. And if you don't do anything, don't apply anything, the switch is open. But if you apply voltage, like a high voltage, the switch is closed. That's how kind of it behaves, okay? Like a switch. And that's how we're using it. The particular device that we have is what's called a 2N2222. And the particular package that we have is called a TO18 metal can package. So the package has this little tab. So if you take this device, and we have 2 of these in our kit, by the way. If you look at this, and if you look at it carefully, there's a little tab. So this is a bottom view. So if you take this little device and turn it upside down with the leads facing up, you'll see the tab sort of on one side. And as you go clockwise, you'll read I won't say these numbers, but the leads are actually corresponding to 1, 2, and 3 emitter base collector. Okay, that's how it matches over here. So if you put this basically this tab sort of facing 45 degrees off the vertical, sort of like this, and then you can read off you can identify the pins 90 degrees off this way. Each 90 degrees you have a different pin. So 1, 2, and 3. So this is basically the bottom view. It's called a TO18 metal can package. And the particular device that we are going to use is called a 2N2222. Okay, 2N2222. And you can see this right here. There's a picture of it. So it's 2N2222A actually. So it's not really that critical what it is, but that is the model number. And that's the view from the top. Okay, so if you look at the can from the top, and if you position this tab on, sort of to your left a little bit, as I'm showing you on the on this picture to the right. So if you look at this, you put the tab over here, then this is the emitter, base, and collector. So if you basically look at it, if you put this tab at like 45 degrees off center like this, and then you read emitter, base, and collector. And of course, you can bend these leads to the position that you would like. Okay, so this is the 20N2222A transistor. You have two in your kit, and we'll be building several circuits using this. And the point is that since the base is a lot more comfortable to be constructed from the right, we'll kind of put these devices as I'm showing you like this, where collector on top, emitter on bottom, and base to the right. Okay. However, these are flexible, leads, and so you can do them different ways. What I'm showing you are just suggestions. Okay. The reason I keep mentioning this is I know that some of you do have circuit building experience, and you may prefer to do it a different way. Okay, that's perfectly fine. All right, so let's take a look at some circuits that we will build. For example, the circuit here. This is a simple circuit with 330 ohm in the collector, 10 kilo ohm in the base, input applied to the 10K to the base through the 10K resistor, and the output taken at the collector. So here's my view of it. I'll mention what these are a little bit, but basically, if we were to look at it a little more closely, this is how it kind of looks like. A little closer look maybe. This is our 330 ohm. This is our 10K, right? And the package that I'm showing you here, they did not have the CAN package, but basically what we're looking at is like this is the this right here is the collector pin. Okay, this is the base pin right here. Okay, and this is obviously the emitter pin. So again, as I mentioned, collector to the top, base to the right of you, and emitter to the bottom. And now what I've done here is obviously I have taken the 5 volt here, and 5 volt is at the top line or top level, the rail, and then we have 330 ohm to the collector, and I have this 10K. Again, these two are connected right here, so these are connected, and then I have 10K, and I have this lead, and so what you put here at the top of this lead is the VIN, basically, right? So if you compare, you will see that that's exactly what's going on, right? So this is your VIN. So therefore, this right here, top of this wire, is VIN. And that's how I suggest that you do VIN. So VIN will be either 5 volts or 0 volts. So if you want to make it 5 volts, just connect the that wire over here. If you want to make it 0 volts, connect it down there, right? If you connect it down there, you make VIN 0 volts. If I connect it up here, I can make VIN 5 volts. So it's as simple as that to measure this circuit. And then you can take the output over here at the collector pin. Any one of these terminals, or right here or right there, that'll be the output voltage. So I hope that's clear. And that's the way I want you to do it, because that's the easiest way. Okay? So that's how this circuit is constructed, right? Okay, that's what we're seeing. So connecting this to the top over here would be 5 volts. Connecting to the bottom would be applying 0 volts. And we'll only be applying those two levels for the other circuits as well. Now the next circuit is 2 of these circuits where the output of one is the input to the next one. So there's 2 of these circuits back to back, and we're going to build it the same way. And we'll measure outputs here and here. And notice that out 1 is the same as in 2, and out 2 is over here. So in 1, out 1, in 2, out 2, but out 1 and in 2 are the same. So that's how I generate these circuits. So let me go back to the construction area to show you how that's done. So what I've done over there, okay, let me put it up. So what I've done over there is I built 2 of these circuits, right? So here's one and here's the other one. Okay, same way, and the input is right here. Okay, that's the only input I'm gonna, so I can take the input and put it over here, and I can make that 5, or I can take the input 1, put it down there, and I can make that input 1, 0. Okay, so I can take it up or down depending on what I want. And of course, if you see that this is the output of 1, and that becomes the input to the next circuit. Okay, so we have first circuit, the second circuit, and the output of circuit 1, collector, is connected to the basically this resistor, which is the input to the next circuit. So I hope you see that construction. It's very, very easy, works very well. And again, here there's only one input, so you're either gonna put it up here or down there and just make your measurements. And that's what this circuit is all about, right? There's only one input that you're gonna put either to 5 volts up here or to 0 down there, and that's how you construct this circuit. We have 2 more circuits. But you know, if you built these, it's going to be pretty straightforward. Here, what we do is we're going to have 2 circuits, okay, with 2 10Ks, V in 1, V in 2, 2 inputs, 1 output. Okay, 2 inputs, 1 output. In this case, the collectors are tied together. Collectors of the 2 transistors are tied together, and that's how this is constructed. Let's take a look at the actual structure over here. So you can see that in this case, what I've done is, as seen on the diagram over here, there's one 330 ohm that both the collectors are tied to, but you have 2 10Ks that are connected to the 2 inputs. And that's what you see here. So you can see that this, okay, this wire actually connects the 2 collectors together, and here is the shared, okay, this is the shared 330 ohm resistor. Okay, and each base, okay, here's the base of 1, here's the base of 2. They each have 10Ks, and these 2 wires are separately going to be connected either to the 5 volts or down here to the 0 volts, right? So you can do that, or you can take this, connect it to the 5 volts, or connect it down here to the 0 volts. So there are going to be 4 possibilities of how to connect these 2 inputs. So 2 inputs, and the single output obviously is right here at the collector terminal of this transistor. So I hope that makes sense. So these are 2 circuits kind of in parallel because they share the collector terminal. But we have independent inputs that are going here to the base of 1 and the base of 2. Okay, so that's how we have this, and that's what is shown over here, right? Okay, and that's the circuit reference down here. Okay, so after a while, you'll be able to look at these and decipher them very, very easily. Hope I'm not making a mistake, but I've checked them over. They seem to be okay, but if you find something, you know, please let me know. Our final circuit is where we take the 2 transistors in series. Okay, so again, we have 2 inputs, which can either be 0 or 5, but in this case, transistor 1 emitter is tied to the transistor 2 collector. And that's what you see over here. Okay, so here's the transistor 1. Again, we're sharing a 330 ohm resistor that's up here. Let's go to the construction tool to see this in action a little bit. Okay, so what we're seeing is here's a 5 volt rail. Okay, 5 volt rail is right here, and here's a 330 ohm that we're kind of sharing. So here's the first transistor, here's the collector, the base, and here's the input for it. But the emitter, okay, so this is the emitter of 1, is going to be the collector of 2. So this is the collector of the second transistor, and it's tied to the emitter of the first transistor, as you can see by the highlighting here. And the base, of course, of the second transistor is over here. And again, this one you can put up to 5 volts, down to ground. Similarly, you can put the transistor 1 input up to 5 volts or ground, and that's what you'll be doing, okay? And of course, the emitter of the transistor 2 is tied to ground, okay? And that's what you're seeing over here. Okay, so this construction is the same as the one that I just showed, and this is the typical diagram. So, sorry, this is the typical construction for the circuit. What you'll be doing is, again, V1, V2 are going to be either 0 volts or 5 volts, and you'll take measurements at V out and maybe some other points, but those are very easily done. Like for example, this point here at the bottom of 330, which goes to the top of the first transistor, I mean, that's really right here. That's right here. So if you put your multimeter right here, the red over here for your multimeter, and for the black, just use the one of the ground terminals here. You'll be able to measure all these voltages. So I hope this is useful. I'm going to put this reference up, and I'm going to put the video up very, very soon. There is really not much to it because once you build one, the other ones are very, very close. But I'm going to include these diagrams for your reference. The only thing to realize is that these pictures right here for the transistor, this package is not the package that you have. The package that you have is the CAN package that looks like this. But again, if you put the tab to your left, sort of facing this way, then the collector base emitter structure will look exactly like this. And you'll be able to build it as shown, basically using this CAN package instead of the plastic package that was shown on the construction diagram. So I hope this helps you. I hope everyone's doing well. And I hope you find this video useful, and I hope you find the reference sheet useful. And you'll have a good time in the lab this week looking at these various circuits with basically semiconductor devices, the LED, light emitting diode, the normal rectifier diode, and then the NPN BJT, the bipolar junction transistor, which we are using as a controlled switch, a normally open controlled switch. So thanks very much for your attention, and I wish you the best of luck in the lab this week, and I hope everyone's doing well. Have a good night. Until next time, I'll be seeing you in class, or if you happen to stop by my office, please come back, and please, if you have any comments, please let me know. Thanks very much. I'll signing off for now. Until next time, bye-bye.